A carousel is initially at rest at t is equal to 0. It is given a constant angular acceleration. Alpha is equal to 0.060 radians per second square, which increases its angular velocity for 8 seconds. At t is equal to 8 seconds, determine the angular velocity of the carousel and the linear velocity of a child located 2.5 meters from the center point P that is shown in figure, and determine the child's tangential or linear acceleration, centripetal acceleration, and total acceleration. Okay. Here, what we require is alpha is given to us. Alpha is equal to, that means angular acceleration. Angular acceleration is given as 0.060 radians per second square. Okay. And then the time is given as 8 seconds. We have to find out the angular velocity of the carousel. So initially omega I is equal to 0. It is the carousel is at rest initially. So omega I is equal to 0. We have to find out omega f. Okay, that is the first bit, angular velocity of the carousel. This is the first bit. So to find out this one, what we do is omega f is equal to omega I plus alpha t. Here omega is equal to 0 plus alpha is given to us 0.060 times 8. Okay. Therefore, omega f is equal to, what is the value? 0.48 radians per second. This is the first bit. Then next second bit, B bit. Determine the linear velocity of the child. Linear velocity is V is equal to R omega. So we have 2.5, R as 2.5 given to us. Okay, 2.5 meters from the center. Here that is. And then omega is given as, we found out now omega 0.48. Therefore, V is equal to 1.2 meters per second. And the next one, linear acceleration. Okay. A is equal to R alpha. So R is known to us, 2.5. Alpha is given to us, 0.060. Therefore, A is equal to 0.15 meters per second square. And then next, we have to find out centripetal acceleration. So AC is equal to V square over R. Am I right? V known to us, R is also known to us. Therefore, AC is equal to 1.2 meters per second square divided by 2.5. Therefore, AC is equal to 0.58 meters per second square. And then next bit, total acceleration. So total acceleration, A is equal to square root of, this is a linear acceleration. So I will write it as linear. He's asking, no, linear or tangential. So to distinguish this R, I will write this as AT so that there won't be any confusion. Okay, tangential acceleration. This is tangential acceleration. And the other one is centripetal acceleration. So this is AT square plus AC square gives the acceleration. Therefore, A is equal to square root of 0.15 square plus 0.58 square. Therefore, A is equal to, what is the answer? 0.60 meters per second square. Now we have to find out the angle direction. Therefore, theta is equal to tan inverse AT by AC. Therefore, theta is equal to tan inverse It is 0.15 divided by 0.58. Therefore, theta is equal to 0.25 radians. Okay, but we have to represent it in the degrees. That is a normal this one. No? So therefore, but we know 1 radian is equal to 2 pi by 360 by 2 pi. Therefore, 0.25 radians is equal to how much? It means 0.25 into 360 divided by 2 pi. That gives approximately 15 degrees. Theta is 15 degrees. Okay, this is what he asked us to find out. Okay, are you comfortable with this? So just simply putting the values in the, substituting the values, nothing beyond that. All are given to us, known to us, given in the data, and then substituting in the equations, we will get the answer. Okay, thank you, bye-bye.